Okay, for this question, we've got a formula for y, and we've got to get dy by dx, so we just used the normal rule for differentiating, decreasing the power when you're differentiating and multiplying by the old power. Then we've got to show that, so that our final endpoint is going to be this point lies on C. Remember, when you're given a point, you're being given an x and a y, and to show this point lies on C, if you take the x value you're given and plug it into there, then the y value you should get is this number here. So you have to show that the x and the y you're given do fit the equation. Then we've got another show that question, so that means this is going to be our endpoint, and we've got an equation of a normal. So a normal is a straight line, so we're going to be using the y minus y1 recipe, but for that recipe we need a point and we need a gradient. So you set up those two little subheadings, and we want the normal at the point P. So the point we've got, we know what P is, so we're okay for a point. Now the gradient, gradient could be any of three things normally, but we've already found dy by dx, so that's a strong hint that it's that one. We need a specific value for dy by dx, so we need our x value again. We need to take a particular x value and feed it into dy by dx, your answer to A, and get a gradient. But then we need to pick up the fact we need the gradient of the normal, so we don't want that basic gradient, we have to work out the perpendicular gradient, and that will be the gradient we need. So when we've got a point and a gradient, we can use the y minus y1 recipe, and the question is kind enough to tell us what we need to end up with. Then the normal to see at P, so in other words, the thing we've just done, in other words, the thing we've just found an equation of, has to cut the x-axis. Well, cutting the x-axis is an x-intercept, and our method for an x-intercept is to take one of the letters to equal 0. So substitute that letter in as 0 in this equation, and out will drop the other letter, and that will give us the point Q. Okay, so once we know what Q is as coordinates, okay, we've got to then find the length PQ. So this is back to coordinate geometry. The length recipe requires 2 points. So one of them is Q. The other point we've got is P. We've got the coordinates for that still. So the 2-point method for length is all you need, and it tells us how we need to give the answer. So I hope that helps on that question.